All right. How's everyone doing today? Sound is my best friend today. The lights are blinding, so let's try that one more time. How is everyone doing today? All right, that's more like it. Okay, so we are here for session FWM204, Optimizing World's Top App, and how Meta uses Device Farm to achieve that. If you're in the wrong room, I suggest you stay. We'll make it worthwhile. So before we get started, tell me if this sounds familiar or if you can relate to it. We all have one or two of our favorite apps that we keep looking at in the day without miss, sometimes too frequently, as we would like. But then we know that app so well that even a slight deviation from its normal behavior catches our eye. Take an example. You have your bank app, for example, or your stock app. And then you just see, oh, the screen is spinning. It's not loading. It suddenly says something went wrong. And then it sets in a cascade of emotions. It happens to me. I'm guilty about it. You go, is the internet okay? Is the app updated? Do I have a slow phone? I need an update. And then worst case, did my app get compromised? Did my account get compromised? Does this sound familiar to anyone? Yeah? Well, hello. My name is Nikhil Devare. I'm a Principal Solutions Engineer with AWS Device Farm, and I help customers, developers, and decision makers, such as yourself, to optimize and improve the quality of your apps. I'm also joined by a special guest today, Jakub from Meta.
Hello, everyone. My name is Jakub Brzmiel, and I'm a software engineer at Meta.
Perfect. Thank you for that, Jakub. So, what are we going to do today? When you leave this room, our hope is that you're able to understand what contributes the performance of an app. What do you mean by optimizing? Like, what are you even optimizing? Is it just load times? Is it network calls? It's a pretty broad term. So we're going to try and get into the specifics. And then how does Device Farm fit into this whole piece? What is Device Farm, and how is it helping customers like Meta achieve their goals? So the way I want to do this is let's start by first laying out the agenda. And the way I wanted to do this was just first, rather than just throwing stuff at you and like, hey, this is performance, this is optimization, let's sort of walk through a primer for mobile testing domain in general. Like, what does the domain of mobile testing entail? What are the challenges in general, irrespective of Device Farm? You as a developer who's working on your local machine or may have CI/CD pipelines, what are the challenges that most customers face? And then second, we'll look at what is Device Farm, how does this fit into this picture? Third, we'll look at how does Meta leverage Device Farm. But more specifically, we're going to let Jakub walk us through his insights on how he began this journey. How has Meta been looking at this? And then at what point did they see a value across different things that they optimize? And then how does Device Farm fit into that picture? And then lastly, I'm going to leave you with what's new, what's coming on Device Farm, what have we achieved in the last year, and then some resources to get you started next. So let's start with challenges for mobile app testing in general. Let's say you're an app developer here, or a team lead, or someone who's been assigned the task of releasing an app. So someone says, go release this app. And you go, well, I need to build it, I need to test it, and then I need to deploy it. So the build, let's just assume that the build piece is figured out somehow, or you somehow generate a build on your local machine. Now you would say, well, I need to test it. And the question becomes, what should I test it on? Should it be a device? Should it be an emulator? That's a good question that most app developers often end up with. So let's look at it from a broad perspective. It's a deep topic. Jakub will touch on a lot of his data points on what's the philosophy that they approach at Meta. But in general, in the last decade since Device Farm has been launched, there's one common theme across all customers. No customer releases or wants to risk releasing an app that has not been run on a real device. However, there are valid use cases for emulators. They provide speed. They might, in certain cases, provide configuration that's more than the device. But I would want to ask you this. Would you really want to release an app that's never been even launched on a device? That does sound a little risky. So for the simplicity of the conversation, let's go with the premise and understanding based on the data that they both have a place. It's an and solution. It's not an or solution. But when it comes to devices, then you say, well, OK, I can go and buy some devices. So you go out and you say, what devices should I buy? There's so many of them. Different screen sizes, different GPU, different make, model, manufacturer, different OS versions, different variants, CPU, the list goes on and on. But you're a smart person. You say, I got this. I think I can figure it out. So perhaps one of the approaches is you go look at your analytics and you say, well, my analytics shows this is the list of devices, or these are the list of devices that are showing me that I should be targeting certain make and models. So you do that, and you go, well, I'm going to buy these devices. Now, note that you might have to keep doing this every few months. Devices keep releasing every other week now, almost. So your analytics might be changing too frequently. So in short, it's a lot of fragmentation, and you need to keep up with it. So then, let's say you go and set up your own lab, and you start plugging in devices and saying, hey, we all can share these devices. We all can use these devices. But what happens in a lab, and the customer pattern indicates so far, and we've talked to several customers who say, hey, I have some devices. There's a data point that emerges that as soon as you approach the sweet spot of 5 to 10 devices and start going beyond that, there is dedicated resource that's needed to maintain that infrastructure. It might sound pretty like, why do you need infrastructure and maintenance for this? But devices, just like in your and my pocket, act weird. They might not have Wi-Fi. They might have stray pop-ups. Sometimes it might just show an app location pop-up saying, this app is using your location. Do you want to continue to allow it? Imagine that happening in the middle of your automation. That just completely blocks the pipeline. So stuff like that, you start to need a maintenance layer, a management layer to maintain those devices. But you're continuing to be a smart person. Let's say you figured that out as well. Then you go out and run on all these local devices. But is that enough that you just run on devices? Let's say you ran on hundreds of devices. And you said, well, here's the output of my regression test. I ran on 100 of devices. And here's exactly 30 devices on which it failed. Now, those devices may be all over the place, different make, manufacturer, model. If you're lucky, it might be something like, hey, it only happens on this manufacturer's device on this OS version. So what you need is really a signal or a pattern that tells you, hey, X percentage of your tests seem to be failing on this device by this much. Perhaps it's gotten slower. You need more actionable results to debug faster, rather than just saying, I'm able to run on this infrastructure that I built. Because your end of the day, your goal is release fast, release with confidence. So with all that domain laid out, where does Device Farm come into picture? So if you've never heard about Device Farm, or if you already know, I'm going to repeat that. It's a fully managed application testing service that provides real devices and desktop browsers for testing on scale. You get secure access to these real devices. Notice the emphasis on real. These are not emulators, not simulators, not virtual machines. These are devices that are in your and my pocket, consumer-grade commercial devices. They are unmodified on a hardware, network, and software level. And why we do that as a design principle is when you release the app, you don't want something that was running from our infrastructure that didn't give you the exact experience that your end user might have when they're running your app. So those are devices, and then we're going to go deeper into the architecture, but you're not managing anything in order for someone to say, what do I need to do on run on Device Farm? You're basically just coming up with your app and test, and that's really it. We don't really need anything. All the underlying infrastructure, even to store your output, that's all managed by Device Farm. You get unlimited storage in that case. It's inside this whole fully managed wrapper. Pricing-wise, that's often something customers immediately say, OK, well, devices are there. What do I do about it? How do you price it? Pricing-wise, you get both pay-as-you-go, and as you start approaching certain usage thresholds where you say, hey, I'm starting to use this more frequently, and there's a threshold that comes where unlimited testing or a subscription model might make more sense. And it's not an or. You can mix and match those. Perhaps your CI/CD pipelines can go on the unlimited testing. Every pull request runs something. All right, so with that laid, let's take a look on the feature set on a high level, and then we'll jump into specifics, and then Jakub can walk us through his use case. So on a high level, you have 3 buckets. Either you want to do, how does a customer journey look when they start testing on Device Farm? So most customers, irrespective of Device Farm, start with a little bit of manual testing, right? And at some cases, manual testing doesn't leave, it lives eternally because you might have some use cases that actually need manual intervention on the device. So you have your manual testing, so that's your remote access. Then you have you graduate to automation testing, so ability to run on hundreds of devices in parallel. That's automated testing. And then I talked about desktop browser, so we provide Chrome, Firefox, Edge, multiple versions. It's a moving window, where as new versions get released, we start supporting those. And the desktop browsers are exposed behind a fully managed Selenium grid. And so customers can, if someone has a web app that says, I want to see how it works on mobile phone, and I want to see how it works on desktop browsers, you can just come to Device Farm and do both. You don't have to fragment your solution. Now, how do you use these cases? Well, it's easy to say, oh, you'd go and do automation testing, but when you start implementing this stuff, you might have use cases like I need access to my staging environment. My CI/CD pipeline is not exposed to the public internet. I have endpoints that may not be exposed. It's on-premise. It's on another provider. The Device Farm feature that provides connectivity and can bring all of this together is VPC. Device Farm can put an iPhone and an Android phone in your VPC. So you don't really have to go and figure this out. Yeah, if you have existing solutions like VPN clients, MDM profiles, it will also support that. But in very short, with a simple config, the entire iPhone can show up in your VPC. And it's easy to say that, oh, I just will run my test. A lot of times folks do customization on the host machine or on the devices. And in those cases, we provide customization capabilities both on test host and on devices. An example could be you're trying to dismiss all the pop-ups on the device, perhaps. Device Farm does that for you, by the way. But let's say you know that some pop-up comes up when you install your app or first-time launch. And it might be a simple ADB command. Or there might be an ADB command to clock your CPU cycle. Jakub will tell us more about that interesting use case. So we provide those customization capabilities for both. And lastly, we also support Android-rooted devices. This is something, when we started out, we didn't really realize, as an ecosystem, Android had profiling and tools that are specifically designed for rooted devices. An example is battery usage. You want to maybe run an advanced profiling saying, what's the battery draw of my app? Well, guess what? Android documentation does provide that for rooted devices on its official doc. So we also support rooted devices. Now, we talked about that. Let's bring it together to summarize what I've been saying. So on a high level, when we are saying what is this service and what does it provide, you want to look at scale. The scale here is you can have multiple users log in at the same time. Each of those users can kick off multiple sessions. Each of those sessions can have multiple devices of different make and models or manufacturer. And so your scale is both vertical, horizontal. There's not restricting you to say, oh, only run on these devices and not those. So that's your scale. It's a fully managed service. I already covered that. There's an interesting slide point there that says server-side execution. Now, server-side execution, think about a typical global team today. You have multiple customers or multiple members of the team, and they might not be in the same location. If anyone here has done automation, you might be familiar with a framework called Appium, perhaps, or just let's say any framework. Now, if the framework is client-server based, imagine someone running from the US region, someone else running from Europe region, someone running from Australia. You're going to see different latencies unless you have all the same stack everywhere. And what that leads to is, if you're running it from a local machine and don't have a CI/CD pipeline, even local executions can lead to different results. So how do you sort of solve that? One way is you say server-side execution. So you don't have to try and solve these discrepancies. You just come to us, say, hey, here's my app, here's my test, and then we run it on the server side. So irrespective of where a person's located, they get the exact same infrastructure, the exact same snapshot of the software, and everyone's running with the same analytics or same output. So that's the idea of server-side execution. For test frameworks, think about what can you run on Device Farm, that it's a lift and shift model. So essentially, if you are trying to run something on your local machine and it runs on a real device, Device Farm should be able to run that. And it will capture everything that you get locally, but provide you with additional artifacts such as videos, logs, screenshots, and performance and network data. And what that helps you is it helps you debug faster. Because your job is to not say, oh, this is a feature or this is that. You just want to solve your problem fast and know where's the problem. So we give you as much as possible configurable artifacts, so you can turn them on and off, and then you can use those. Customization, I already talked about that. There are two that I want to highlight. You can mock locations. If you have a network location specific feature in your devices or in your app, you can mock that. You can just give us the latitude and longitude, and we will mock that particular location. Note that devices in Device Farm are available in US West 2 region today. So mocking location helps you overcome some of the net or location-aware features that you might have. And lastly, we also have network emulation. So if you want to say, hey, how does my app behave in a bad Wi-Fi network or on 2G or 3G or 5G? And you want to change it dynamically on the fly. One run comes with 5G. Oh, you went in a tunnel. Now what happens? If you want to emulate that, we also have network emulation capabilities that you can use. And then all of this, you don't expect to run manually one by one. You need a CI/CD flow to integrate this eventually when you're in a mature release cycle. And that is the least heavy part of the lift with Device Farm. In my 10 years with the service since launch, we have never come across a single CI/CD system, I hope that says, that we have not been able to integrate with. And the reason being that we have a variety of first-class plugins that are built by Device Farm teams, so Jenkins plugin, Gradle plugin, and the functionality is also exposed through AWS CLI and AWS SDK. Now, our question often comes, can I get my own devices? Is my data going to be OK? I have some unreleased app. So you have two device offering choices in Device Farm. Number one, you have public devices. So when I say shared devices, they are secure shared devices. And what that means is customer A comes in, runs the tests, might produce some artifacts, might produce some videos, some other thing, change some settings, install some certificates, and be done. But we maintain multiple instances of each of these devices that you see. But after every customer run is done, we delete everything: browser settings, history, cookies, MDM profile, VPN profiles, trust certificates. And we lock down things that we are not sure whether we can clean. So there's no second guesswork. We go by everything is locked down first, then we keep on expanding. So that's public device model. The advantage there is it gives you the breadth. Because we keep adding devices, so as they come, you get breadth, and the depth is built into it because we are not just putting out one instance of a particular device. It's multiple devices. If you see one device with one OS version, like a Google Pixel 8 running 14, and a Google Pixel 8 doesn't run 13, but let's say it also has 13, it will be multiple instances of the same thing. And private device, as the word indicates, dedicated devices. No one even knows they exist in your account. They're only available to one or more of your AWS account. They give you the secure access to VPC connectivity. And then you can do advanced scenarios. Let's say you have a VPN profile that needs to be installed, or you need to have your state of the phone exactly as it was when you left the session last time. You can do those. Or maybe you want to reboot the device. That's also a use case. So you can selectively do those things with private devices. All right. So just to give you a high level of flow before Jakub takes over, is, as I mentioned, in order to run tests on Device Farm, you need three things, only three things. Technically only two, but third is the selection. So you need just your app. It could be a native app, hybrid app, or a pure web app. So you have an IPA file or a .apk file, or you just tell us, hey, it's a web app. It's going to open in a browser. So you take that one. Number two is you take your test framework. It could be one of the popular test frameworks that you might have chosen. Even if it's a completely custom framework, remember that customization capability, you should be able to run on Device Farm. So that's input number two, which is a zip file. Then you select devices on Device Farm, and it could be multiple devices, hundreds of devices, thousands of devices. Once you select those and kick off the execution, when you say go schedule a run, Device Farm spins up the number of host machines for each of the devices. So for example, if you selected 100 devices, said go run 100, Device Farm will spin up 100 host machines. If it's an Android device, it will be an EC2 Linux machine, or EC2, if it's a Mac machine, if it's an iOS device, it will be a Mac machine. So and there's a one-on-one correspondence between the machine and the device. So that's the level of isolation. Each host gets its own device, and then each device gets its own network, its own isolation. So even devices in the data center, they're just sitting near each other. They can't see each other. There's no detecting the Wi-Fi. They don't even live on the same subnet. So that's the level of isolation you provide, even with your own multiple sessions in your own account. So that's the high level. With that, I'm going to pass it to Jakub.
Thank you, Nikhil.
Yep.
Hi, everyone. A few words about myself before I dive in. I was responsible for integrating AWS Device Farms into Meta infrastructure. I used to work on a platform that measures performance of mobile application before it gets released. But I'm still a huge facilitator of device testing and help other teams in Meta use AWS Device Farm. I'm going to start briefly by talking about release process of mobile applications in Meta. Then I'm going to talk about two areas where we find device testing especially useful, which is correctness and performance. And I'm going to close with a short summary. Why do I believe device testing is important and how AWS Device Farm enables us in doing so? But let's start about releasing mobile applications in Meta. Every week, Meta releases one of the most, if not the most popular application in the world. You might be familiar with some of them, probably have them even installed on your phone right now. Each of those applications have hundreds of millions of users worldwide. With that amount of exposure, any issue can impact millions of customers. Small bugs will impact people here and there, but the consequences of a big one are on completely a different scale. So let's dive into the journey that takes an idea from developer's mind into your phone. How does code get shipped in Meta? You might be familiar with some of those boxes. Truth be told, this is actually a very simplified flow of the release, but truth be told, I bet release in your companies, you look fairly similar. It all starts with engineer working on their dev machine and typing the code. The IDE will provide rich feedback about the code, type checking, they will surface the compilation error. Some developers might decide to run unit tests at a time. Some of them will wait for next phase. Depending on complexity of the feature, developer will likely spin up their emulator, test it, maybe add some end-to-end tests or unit tests. Once they're pleased with their code, they submit their diff for the review. While other peers review the diff and code changes, we run simple end-to-end tests and unit tests. Once everything passes and diff gets approved, we integrate it into the main branch. Once in the main branch, we start running a little bit more advanced end-to-end testing to make sure nothing gets broken. Those tests usually either run a little bit longer, and we don't want to interrupt flow of development early on with such a long tests. There might be a little bit flakier. Unfortunately, we also do have those. Or they might be using limited resources. Once everything looks okay, build gets promoted as release candidate. It gets sent to QA team for manual testing and or deployed on developers' machines internally in Meta. Once everything looks good and there are no bugs, the build is ready for release. This is the flow that I believe, in very simplified form, your company is using as well. But it has few major flaws I want to talk about. First, it relies on humans in final step for testing what ideally should be automated. Humans make mistakes, and we've talked how expensive they can be. Besides, we, software developers, we love automation. It is said that we're going to spend 5 hours automating 5-minute tasks, which I personally find true. The other problem is some of the bugs, simple bugs, are discovered very late in the release pipeline. QA gets a build for testing, and it turns out the basic functionality is not working. Either you cannot send a message, or in worst cases, the whole application crashes. This is problematic because of two reasons. First, QA is blocked on testing because the app doesn't start. They cannot test any other functionality. Second, the developer who wrote a feature and now have to go and fix it has already moved to coding something else. Now they have to come back and pay what I like to call a context switching tax and fix it. Finally, performance tests are outside of the picture in this release pipeline. Humans have very hard time detect small performance regression. We're not going to see 20 milliseconds performance regressions. And we used to release app with such a regressions. Find out later. Correctness. Correctness is the first area I would like to talk about. It's a little bit simpler than performance that I'm going to talk later, mostly because usually when it comes to correctness, the output is binary. Either something works or doesn't. This, of course, is excluding the flakiness, which I'm not going to be covering today. Before I'm going to dive into specific examples of correctness, I want to talk about our phones. Those phones that we carry in our pockets, backpacks, or purses are extremely capable devices. They can do a lot of work. But we, as software developers, we're not falling behind. The apps we're developing are squeezing what's possible on those phones, and they're reaching the limits of the phones. And the limits are different between different devices. And I'm not just talking about Android and iOS. But they're also different between devices and emulators. Conditional code execution based on an environment the code runs in is one of the most common cases we can see in our code base. And I bet you can recognize those two pieces of code from your code base as well. Based on the environment your code runs into, you might want to execute something else. It's a very useful feature, especially when some shared library it's not available in one environment or the other. Some functionality differs and you want to take this into account. Or you basically want to do some extra logging during running on emulators. As powerful technique it is, it also comes with a problem. Code that's not being executed can potentially have bugs that's going to be discovered in the real world once the application reaches actual physical devices. GPU is the next topic I would like to talk about. And it's an area where emulation can be especially problematic with. The difference between phones and emulators can lead to many issues related to GPU. We've encountered real-world scenarios when the combination of specific CPU and GPU cause problems in the real world. Luckily, AWS Device Farm, with help of AWS Device Farm, we're able to acquire those devices and add to the pool of our devices. As I mentioned earlier, if you're using GPU in your app for any kind of video processing, you're most likely already hitting the limits of what's possible on devices. And what's possible on devices differs from what's possible on emulations. Those differences can lead to poor GPU performance, crashes, or many other issues. That's why if your app is using any advanced GPU processing, it is crucial to test it on the actual physical devices. Now let's talk a little bit about performance. Because of my background, it's an area that's a little bit closer to my heart, and I find it a little bit more challenging as well. Humans will not recognize a subtle performance regressions like 10 or 20 milliseconds. We're going to notice half a second, but most of the cases, performance regressions are very small. The other reason why it's a little bit interesting topic is the same way we as software developers pushing the limits of what's possible on devices, the same way Meta is pushing the limits of possible on AWS Device Farm. And don't get me wrong, whenever we hit those limits, we usually work with AWS Device Farm in moving them. The great example is rooted devices, which I'm going to talk in a minute. When I started working with Nick Hill 2 or 3 years ago, AWS Device Farm didn't have rooted devices, and that was one of the requirements we had for them. I know that Nick Hill had to go to his team in the middle of, after planning, through the half of the planning away and incorporate our request. Yeah. Let's start with a simple thing. How do we even measure the performance? You might be familiar. We take a timestamp, run the code, take a timestamp again, subtract it, there's our duration, we're done. And it seems simple. However, there is one big issue. There's a bunch of noise in the system. So before I dive into techniques that we in Meta are using to minimize the noise when running performance, I want to talk about the impact of the noise. Above, in the graph above, you can see a signal that app performance is generating when we don't applying all the noise minimization techniques. A short disclaimer, we still apply some of them as they were difficult to disable. It was difficult to disable all of them when I was taking a screenshot. Below, you've got a graph with with all of our noise minimization technique applies. As you can see, graph is much smoother and allows you to detect smaller performance regressions. We can categorize noise into two areas: internal and external. Internal coming from the phones, and external coming from outside. And I want to start focusing on the latter. Our applications rarely run in isolation. They usually do a bunch of server calls, either to fetch configuration, fetch user details, cache some settings, fetch any other needed things for smooth application running. Those server calls differ. They can take from 300 milliseconds to a few seconds, depending, are we hitting a server in the same region, in the same continent? Is the server busy? Are we in the peak hours or we off hours? Are the underlying components, maybe there's some maintenance on the database and request takes a little bit longer. We're getting into the strange situation where we're trying to detect 5, 10, 20 millisecond regression on a test that runs between 5 and 10 seconds. In order to minimize the impact of the server calls, we in Meta proxy all the requests from the app through our local recording proxy and record them. We record request and response that we make to the server. Later, when we actually run performance tests, we replay the responses we've recorded. This is the first area where AWS Device Farm and their customization allows us to succeed, because we can do a lot of interesting things there. When we're talking about devices, everyone thinks that the same devices behave the same way. What we've discovered is even the same devices produced by the same producer, by the same manufacturer, same model, same CPU, same OS version, might have a slightly different performance profile. What does it mean is if you're trying to detect regression that takes 10 milliseconds or 20 milliseconds, they might successfully interrupt you in it. Ideally, we would run the same test on the same device, always. But realistically, that's not possible. Devices might die. There might be an OS upgrade or any other changes. That's a perfect transition to a next topic that I want to talk about is, what does it mean that the app is slow or fast? The actual question you want to ask yourself is it slower or faster than when it used to be? That's why in Meta, we don't compare performance values with our historical data. Rather, we run on the same device changes before and after. And this is another area where AWS customization allows us to do, because we have to reinstall the app in the middle of test running. So we run application before and after, run performance on it, and then calculate the percentage difference. Is it 10% slower, 5% faster? This allows us to always run on the same device and reduce the noise coming from the different device models. The next topic I want to talk to you about is something that probably most of you are familiar with and already doing. The more data we're going to gather, the more accurate results we're going to get. Ideally, we would like to see a normal distribution from our data measuring. However, we at Meta, we're aiming right now and running at least 50 trials. You might ask, why 50 trials? Once we run 50 trials before, 50 trials after, so we can compare the differences. We have to install app, we have to reinstall in the middle, we have to do some preparation between each of the trial, we have to do some data gathering after each of the trial, done some summary after all of the test running. We are already hitting 2.5-hour limit that AWS Device Farm is imposing. I know for a fact that you can make it higher, like the limit 2.5 hours is not set in stone, it can be changed, but we find 2.5 hour limit to be just enough for us to get the signal for our performance tests. We've talked a little bit about external noise. Let's focus now on our phones. When we're running the tests, the phones do much more than just run the tests. There are a bunch of background processes running that's occupying CPU, that's using the CPU, which being taken away from our performance testing. Those background tasks might do some maintenance work. They might check if there's an OS upgrade, or even worse, they might be downloading an OS upgrade while we're running performance tests. In order to remove their influence, we at Meta, we analyze tasks which run on the processes which run on the phone, see how much CPU they're taking. Can we terminate them? Can we use the phone after we terminate them? The answer is not always yes. And if everything is green, we terminate this process before each of the performance tests running. This allows us to have a lower noise coming from the phone itself. It's also the first area where we're using rooted devices, and that's why we needed rooted devices when we started working with AWS Device Farm. Some of those processes might need an elevated permission to be terminated. When application runs, it stores state in memory and on disk. When it's being closed, it usually dumps its in-memory state on the disk, so whenever next time it starts, it's going to read from it. This on-disk state contains a lot of information, like application configuration, user preferences, user information, some cache objects. Every time the application starts, it reads the on-disk state, and it influences its initial state. Suddenly, we're running into the situation where we're comparing apples to oranges. It's not exactly the same what we're trying to compare when it comes to our performance measuring. That's why what we do in Meta is we take a snapshot of how the on-disk state of application looks like after the first trial and restore it before each of the trial. This approach minimizes the noise coming from the different on-disk state and allows us to detect even smaller performance regressions. Temperature is, I think, one of the most interesting sources of the noise, and I hope at least it's something that you didn't expect to see here. If you think about our phones, CPUs especially, those are extremely capable units. They can do a lot of work in a short burst of time, and they can last the whole day on the batteries that's embedded in the phone. They were not designed to do constantly a lot of work. If you ask me, running tests, performance tests for 2 hours matches the definition of constantly doing a lot of work. When we do it, the CPU frequency is being raised by a phone. CPU starts using more energy. It starts producing more heat. It starts to overheat. The phone notices it and downclocks the CPU to make sure it's not going to get damaged. So we run into this interesting situation where the half of the test or initial part of the test is run with the CPU with the higher frequency, and the remaining part of the test is running with the CPU with the lower frequency. So suddenly we either are, depending on ordering, if we always do before tests, if we always do older application first or newer application first, we always might see improvements or regressions. In order to minimize the impact of the CPU frequency changes, we in Meta, we manually downclock the CPU to values where it no longer overheats. So we set the value of the CPU frequency to such a level that we can run it for a long time, and it's not going to draw too much energy. We also, to ensure that there is no frequency changes, We read the value of how many times the CPU frequency changed before the test and after the test. And if those two values do not match, we're going to make the test as invalid. This is another area where AWS Device Farm is useful with the rooted devices. In order to manipulate the frequency of the CPU, you need an access to the root account. When building a system that's dealing with performance regressions, you're going to face an uphill battle with false positives. Those false alarms can be time-consuming and frustrating, but they're inherent part of the system. That's why in Meta, we take an approach to prioritize accuracy over speed. Every time we're not going to fire an alert that we see a regression from a single data point, but we're going to analyze the trends and history of the given test. What happens is we usually takes a little bit longer time before we actually confirm there is a performance regression. It might take a little bit longer before we're going to kick off the post-regression workflows, such as firing the alert, notifying the on-call, or doing a bisect. By taking a little bit more cautious approach, we reduce the noise generated by the system and improve signal-to-noise ratio. It allows on-calls to be focused on the genuine performance regressions and making the team more effective and efficient. So let's do a quick summary. Why do I think device testing is important and how AWS Device Farm helps us with it? And I know the question that most of you, if not all of you, ask yourself right now. Do we actually need physical devices? They're more expensive to buy and to maintain. They're flakier. They don't scale as well. A great example is, in many cases, you have to physically interact with the device in order to either boot it up or reboot it when it goes in a bad state. They don't build racks to put devices out of the box to put devices in data centers. They come with a bunch of restrictions, such as there's no root access out of the box. And you're right, emulators will cover you in 90, 95, maybe even 99% of the cases. But the question that Nikhil asked is, would you release an app without even once running it on devices? What would happen if the app you're going to release going to crash on devices when it didn't crash on emulators? How much damage can the crashing app on devices can do to your brand? I like to compare testing on physical devices to insurance. All of us who had an insurance, I bet no one hopes to use it. Nobody gets into the car in the morning and say, oh, I hope I'm going to have a fender bender so I can use my insurance. We have it, so when we have to use it, we're like, oh, I'm glad I have it. And this is exactly with the devices. We test on devices, so when we catch an issue on the device, we're like, oh, I'm glad I did test it. It would have caused a big damage to my brand. So how does AWS Device Farm support us with all those cases? I did talk about it through the slides, but let me just do a quick summary. First, it provides us with a huge variety of devices. It's a fun fact. We run right now, I think, 10-year-old device in AWS Device Farm. There is a difference between running a lab with hundreds of devices of the same type and hundreds of devices with dozens of different types. You're going to see that every time you add a new type, new model of the device, it's going to get more complex. Next, their devices have high availability. I know that they monitor a bunch of metrics on the device and around the device to detect early signs of failure. Once those metrics drop below acceptable level, they will silently replace the device behind the scene, making sure it's not going to die in the middle of tests, and also their service going to have a high SLA. The rooted devices is the next area where it's especially useful for us. I did talk about terminating some of the processes that uses a lot of the CPU, as well as CPU frequency manipulation. We wouldn't be able to do it without rooted devices. And last but not least, customization scripts allow us to do, like to say, a lot of random things. A great example is setting up the proxy to record all the communications between app and a server and mocking it, or reinstalling the app in the middle of testing. Thank you, everyone. Back to you, Nikhil.
All right. Thank you, Jakub. I would like to say, firstly, thank you also. I know I've said it enough times, but every time we've worked with Jakub and his team, we've learned a thing or two on how customers are using it and pushing the limits of what's possible in mobile app testing. So I appreciate all the insights over the years. I wish we continue to build more cool stuff. All right. So while working with Meta over the years, I think one of my favorite quotes ever, and I remember Jakub being really silent on the call in the start, and he just said, I have some feedback for you. And I said, what? And he said, it just works. I said, well, I know it works. I've seen your system. We've looked at it. He says, no, this is my best reward. Someone from the team just used it for the first time, paused, and it just works. And I think that was the most rewarding experience. We were just chatting yesterday, actually, and just bringing this up, that he was really passionate and reading about a book and saying, Don't Make Me Think by Steve Krug. He's like, I love that book. But that resonated me with so well, because that's exactly what, while you're navigating this whole web of automation testing, is what Device Farm's trying to do, is don't think about devices, don't think about the infrastructure, don't think on how would I solve this problem. Just focus on your app and your test. We got you on the rest of the stuff. That's the principle I like. I think I like the example. I'm going to read the book. OK, so I wanted to capture what have we been up to and what are some of the things we're venturing into and trying to solve for you. So some of the things, if you've already used that Device Farm in the past, if not, no problems, I can recap. But Device Farm out of the box supports a lot of the popular test frameworks, to name a few: Appium, XCUI, XCTest, and multiple flavors of Appium, and so on and so forth. But these frameworks evolve over time. They keep adding more functionality. They keep advancing what's possible on those devices. And one of the examples is XCUI tests. And XCUI now has the ability to do test plans. They have the ability to spin off multiple emulators or devices and then test them in parallel. So now we support out-of-the-box experience for XCUI test plan and more advanced scenarios. Some of the examples are you can run XCUI test plan with just an IPA file. You no longer need the source code. Just give it a plist file. Maybe you need to pass an environment to your XCUI test file. That was never possible. So it supports all of that on a broader spectrum. Again, the design principle for Device Farm is don't fight the ecosystem. What that means is if you are used to doing things a certain way on your local machine, we don't want to introduce anything new just because you have to run it on Device Farm. You're going to do a lift and shift off your workflow to Device Farm. And this works towards that. We observe that there's multiple ways to run this, multiple ways to configure this. Second one is the improved remote access. This is manual testing. Earlier I mentioned all the devices in Device Farm in the US West 2 region. So imagine someone in Australia or Asia region making a click on a device, which is going all over the network, and then hitting the US West 2 device, and then it rendering a video frame and going all the way back. While we do a job that's acceptable, and customers rarely tell us that, hey, your Android device doesn't seem to be going fast. We did observe last year that on certain make and models of iOS, for example, with certain OS versions, the combo could exaggerate things. And it's just enough that you start feeling it, like saying, oh, it took a half a second more. I wish it was a little zippier. So this year, just recently in the last 2 weeks, we've improved the remote access performance. It's slowly being deployed. It's available on iOS 18. But it has resulted in a 36% improvement in latency. So now iOS feels more natural. We've covered everything that we couldn't earlier. Speaking of being fast, the Android test host machine. So when I said you run a device, you run a test on Device Farm, there's a host machine, there's a device. So you also need the host machine to be performant, not just the device. So now we've updated those host machines. Those host machines not only run tests, end-to-end tests, 33% faster across all customers, But we're also seeing that we've released wider selection of pre-installed dependencies. An example is you might need Xcode 14. Oh, some test requires Xcode 13. No, I need Android Platform Tools version something. I need Python 3.16 for this environment. Rather than you fighting it as you do it locally, we're taking it one step further and saying, just forget about that. Here's a one line. Just say, Device Farm CLI, use Python 3.16, and it will take care of all the dependencies throughout your environment for you. So again, we're trying to make it simpler than it would be even in your local setup. So even when you're doing a lift and shift, you can possibly just not do installation of dependencies and other stuff in the environment. Lastly, console improvements, quality of life improvements for most part, but also for the first-time customers who's never used it and just want to try out, perhaps one of you after this session. It's now much faster to get onboarded and have the first experience. We've learned, and so there's a bunch of whole console improvements that help you land the first test faster. And then lastly, faster error debugging here is a broader topic, but essentially the goal is when something goes wrong, it's one thing to say, this failed. And then there's another piece like, well, what do I do about it? Do I go read docs? What do you expect me to do here? So faster debugging takes a slightly approach that's pushing beyond what we generally have done in the past, and it's telling customer, hey, we see your test failed or your run did not schedule because of X, Y, Z reason. It could be that it's for one of these reasons, and here's how we think you should fix it. So it's a more comprehensive, okay, think with you, give you the error messages that are actually useful. And because we did the remote access improvements, videos can now stream for both iOS and Android on 25 frames per second. And it tries to recalibrate according to your network. So if you're like going near 4 megabits per second on network speed, it'll tell you, hey, I'm going to adjust based on your network speed, perhaps reduce the frames per second rather than saying, well, freeze, I can't do anything. So that's about it today. I really want to thank everyone for coming over here and giving us your time. And I hope you have something to think about when you go back. Please let us know in the feedback. It's always good to meet all customers and hear back from them. Thank you for your time today.